Dear students, until now we were concerned with the descriptive statistics, that is, methods to summarize and organize data in the form of tables, charts, and also some descriptive measures of center, measures of variation, skewness, kurtosis, etc. But in inferential statistics, our concern is we have to make inferences about population parameters using sample. As I told you earlier, the entire population is unknown. We have only a sample, and the sample is used to make inferences about population. And this branch of statistics is known as inferential statistics. And in inferential statistics, sample information is used to make conclusions about population. And as population parameters are unknown and the value of sample vary from one sample to another sample, we never know that our conclusions are always correct. Stated differently, there is uncertainty about the conclusions which we make about population parameters using samples. So uncertainty is inherent in inferential statistics. Uncertainty is inherent in inferential statistics. And the science of uncertainty is known as probability theory. The science of uncertainty is known as probability theory. Probability theory. And probability theory provides the mathematical basis for inferential statistics. Probability theory is the basis for inferential statistics. So, in this class and also in the subsequent classes, we will discuss some basic probability concepts. This is not a formal class in probability theory. If the students are interested in probability theory, they are supposed to read standard books on probability theory. This class is concerned with how to use the concept of probability in inferential statistics. How to use the concepts of probability theory in the context of inferential statistics. That is all. And we will not discuss in detail the various aspects of probability theory. So we start with what is known as the equal likelihood model. The equal likelihood model. We start with, in order to see how probability theory is used in inferential statistics, we start with what is known as the model of probability, namely the equal likelihood model. To explain this, suppose that 5 top state officials are governor, denoted by G, lieutenant governor, denoted by L, and Secretary of State denoted by S, Attorney General denoted by EA, and Treasurer denoted by T. GLSAT, Governor, Lieutenant Governor, Secretary of State, Attorney General, and Treasurer. Suppose that we take a simple random sample without replacement of two officials. Simple random sample without replacement. And simple random sampling and associated concepts were discussed earlier. And we have simple random sampling with and without a replacement. So we assume that two officials are taken at random without a replacement. And suppose that we want to find out the probability that we obtain a governor and a treasurer. We obtain a governor and a treasurer. We want to calculate the probability that we obtain a governor and a treasurer. Now, we have 10 samples. The samples are GL, GS, GA, GT, GL, GS, GA, GT, then LS, LA, LT, then SA, EST, and ET. These are the 10 samples. 10 samples. And in these 10 samples, we have to obtain governor and treasurer, G and T. And there is only one sample which includes both the governor and treasurer. So the probability that we will get a governor and a treasurer is 1 in 10 or 0.1 or 10%. That is, the probability that the sample selected is both a governor and a treasurer is only 1 by 10. So now suppose that an attorney general is included in the sample. Only one attorney general. We have 1, 2, 3, 4 attorneys. So 4 by 10 or 0.4 or 40%. So 40% of the samples includes an attorney general. 10% of the sample includes both the governor and the treasurer as examples. And as this example shows, when the outcomes are equally likely, probabilities are nothing more than percentage. Probabilities are nothing more than percentage. Here 10 equally likely outcomes. And what are the probabilities? 10%, 40%, etc., etc. Now we having defined what is meant by the equal likelihood model, let us see the probability for equally likely outcomes. Let us calculate the probability for equally likely outcomes. Now, suppose that an experiment has n possible outcomes. Selecting two top officials from a total of 5 officials can be considered as an experiment, and it has a total of n equal to 10 outcomes. n is equal to 10 outcomes, and also assume that each outcome is equally likely. Then an event and suppose that an event can occur in f of these ways, then the probability of that event to occur is f by n. Suppose that an experiment has n outcomes. An event we will discuss event later, can occur in f number of ways. For example, the event is governor and treasurer, so it is 1 by 10. Is an attorney, it is 4 by 10. So the probability that an event can occur is given by the formula f by n. F, the probability of the event is given by f by n. This is very important, remember this always. An experiment can occur in n ways, and f of this is favorable to event A. Then the probability of event A is f by n. For example, if the event is both the governor and the treasurer, or an event is an attorney general, like this. Now, given this, let me just define what is. Let me give a few definitions. What is an experiment? Selecting the top officials is an experiment. An experiment is in general is a process that leads to one of the several possible outcomes. One of the several possible outcomes. Now, what is an outcome? What is an outcome? An outcome is some observation or measurement of an experiment. An outcome is G and T, governor and treasurer. It is an outcome of an experiment. Or you consider the playing cards, total number of cards, 52 cards. A pack of playing cards consists of 52 cards. And suppose that you are drawing a card randomly. Then an outcome may be queen on diamond. Queen on diamond. Or from this you take one randomly, that may be an attorney general or a governor or something like that. Queen of diamond is an outcome. A single outcome for an experiment is called a basic outcome or elementary outcome. If there is only a single outcome, it is known as basic or a elementary outcome. Basic outcome or a elementary outcome, a single outcome. And so experiment, outcome, basic or elementary outcome, then the sample space. The sample space, also known as the universe, is the universal set S associated with an experiment. Sample space is the universal set, or it is the set of all possible outcomes of an experiment. Now, if this is an experiment, S is 10. If this is an experiment, S is 10. Each one is an outcome. Each one is an outcome. And if you consider only one outcome, it is a basic or elementary outcome. And what is the sample space? Sample space is nothing but all possible outcomes associated with an experiment. So like drawing a card, selecting two officials. These are all experiments. Then an event. An event is a subset of the population. Event is a subset of the population, and it is a set of all basic outcomes. An event is a subset of the population, and it is nothing but the set of basic outcomes. And in the example we have considered, the experiment of taking two officials from 5 is an experiment. All the 10 outcomes are equally likely, and an event is a sample includes Attorney General. An event is a sample includes an Attorney General, say, as we have seen, 4 by 10. It is an event. It is a basic or elementary outcome, means each one is a basic or elementary outcome. And event is the outcome includes an attorney. So we are not interested in basic or elementary outcomes. We are interested in events, and event is a subset of the population. Or consider the case, an ace is drawn out of a pack of 52 cards. An ace, and the card has a total of 52 numbers, and there will be 4 aces. So it is 4 by 52. The 4 by 52. It is the probability of the event. The event is here, ace, from a pack of cards. So given this, we can calculate the probability of an event as PE as equal to NA by what is known as NES. Probability of any event can be calculated as NA is the number of elements in the set of event A. Number of elements in the set of event A. And S is number of elements in the sample space. For example, here the sample space is 52, and number of sets in this event is 4. 4 A's in a pack of 52 cards, or 4 by 10, because the event is an attorney. 4 by 4 is number of elements in the event, number of elements in the set of event A, like that. So these are some of the basic definitions. What is an experiment? What is an outcome? What is basic or elementary outcome? What is a sample space? What is an event? And we will discuss events in a little more detail later. Now, given all these definitions, etc., let us define what is meant by probability. Actually, probability is a generalization of the concept of percentage. When we select a number at random from a finite population, probability is nothing but percentage. When you take a number at random from a finite population, probability is nothing but percentage. Whether it is in the case of selecting a card or selecting an individual from a finite population. Here population is 10 only. Here population is 52. So the probability is nothing more than a percentage. But this is not enough. We have to give a general interpretation of probability. For example, when we say that the probability is 0.4, that the probability is 0.4 that an accident will happen if the driver is drunk, or what is meant by saying that the probability is 0.3 that your computer will crash or fail while you're writing a term paper, as an example. So, we have to give a general definition to probability. There are many definitions, highly sophisticated, etc., but we consider for our purpose the frequentist interpretation. The frequentist interpretation of probability. It considers probability of an event as the proportion of times it occurs in a large number of repetitions of the experiment. Probability of an event is the proportion of times it occurs when the experiment is repeated a large number of times. For example, when we say that the probability is 0.4 that there will be an accident if the driver is drunk. Suppose that we cannot experiment with drunk driving, but suppose that drunk driving happens 1000 times. Then, if probability is 40% that an accident will occur, there will be accidents 400 times. That is the frequentist interpretation. How frequently an event happens. How frequently, in this selection of officials, how frequently an attorney general is included. 4 out of 10. So the probability is 40% that there will be an attorney in the sample selected. Or we say that if 30% is that your computer will fail, then if you write 1000 term papers, your computer will fail 30% of the times. That is the definition of probability as it is interpreted as the frequentist definition of probability. Frequentist definition of probability. And empiricist or frequentist interpretation cannot be used as a definition of probability. One common way to define probability is to specify a probability model. One common way to define probability is to introduce a probability model. The equal likelihood model we have introduced is an example. The equal likelihood model we have introduced is an example of a probability model. Now, having defined what is probability, we have to consider 3 properties of probability. One is the probability of any event is between 1 and 0. The probability always lie between 0 and 1. If an event will not occur, its probability is 0. And if an event is sure to occur, then the probability is equal to 1. So the range of values of probability is 0 to 1. 0 means the event will not occur. 1 means the event will occur. Now, so these are the 3 properties of probabilities. And this probability model, the equally likely model, which we have described, will be extensively used later to define random variables, probability distribution, and related concepts.